Welcome everyone. The circuit that is displayed here R1 and R2 10 ohm and 15 ohm are in parallel combination, and R3 and R4 3 ohm and 1 ohm are connected in series combination. And this circuit diagram, this combination of the resistors is basically connected to the 20 volt potential source. Since R1 and R2 connected in parallel combination, so we have to calculate what is the parallel equivalent of these two resistances by this formula, that is R12 is equal to R1 into R2 divided by R1 plus R2. Obviously here I have given this R suffix 1 2 is the equivalent of the resistance R1 and R2. What is R1? R1 is 10. What is R2? R2 is 15. So R1 into R2 divided by R1 plus R2 simply becomes 10 into 15 divided by 10 plus 15. So 10 into 15 is 150 and 10 plus 15 is 25. So 150 divided by 25 becomes 6 ohm. R3 and R4 are connected in series combinations. Now if I find it out what is the series equivalent of the R3 and R4, that is R3 plus R4. R3 plus R4, because in series combination the resistances are simply added. We are basically doing the algebraic sum of the resistances. So R3 plus R4 is simply 3 plus 1, that is we can say 4 ohm. Now if I try to draw the equivalent of this circuit, so 20 volt source is here, R1 R2 parallel combination, so a single resistance will be here instead of the parallel combination of R1 R2, and that is the equivalent of R1 R2. R3 and R4 is series, and we have calculated what is the equivalent of these two. So I am naming these resistors as R3 and R4. So now we can see here R1 2 and R3 4 are in series combination. So the equivalent resistance of this circuit is simply, we can say, the series combination of R12 and R34. What is R12? R12 is the 6 ohm. What is R34? R34 is the 4 ohm. So 6 ohm plus 4 ohm is equal to 10 ohm. So 10 ohm is the equivalent of this circuit. Let me draw. So this is a simply a resistor, and we can say that is 10 ohm. Okay, the potential is 20 volt in each of the circuit because it is not changing. Okay, so what is the current through the circuit? If I want to find it out, then very simply by Ohm's law we can say the current, what is the main current of the circuit, that is capital I. Capital I is equal to 20 volt divided by 10 ohm, and that is my 2 ampere. So we can say this 2 ampere is flowing in the circuit because it is the main current. Simply here also, the direction should be changed here. The direction, because the current is coming from the source, so the direction should be this. And here also the current flow is 2 ampere, and this 2 ampere is flowing through R12, this 2 ampere is flowing through R34. Now I return back to the main circuit. The current which is coming, which is 2 ampere, okay, which is basically coming through here, and R1 R2, this current should be divided because these two are connected in parallel combination. Okay, so let us say the current through R1 is I1 and the current through R2 is I2. Okay, and I1 I2, if I sum these two, then this will be 2 ampere, and again I1 I2 joins, and again it becomes capital I, that is 2 ampere, and 2 ampere flows through R3, 2 ampere flows through R4, and again it returns back to the negative end of the 20 volt. Okay, so we already obtained what is the current through the resistor R3, what is the current through the resistor R4, but we are still trying to find it out what is the current through the resistor R1 and R2. But before that, we try to find it out what is the potential drop across the resistor R3. Let us say V3. V3 is simply I3 multiplied by R3 according to Ohm's law, What is I3? I3 is your 2 ampere. R3 is 3 ohm. So you can say 6 volt. So 6 volt is the potential drop across R3. Okay, 6 volt is the potential drop across R3. Now if I try to find it out, what is the potential drop across R4? That is I4 multiplied by R4. What is I4? I4 is 2 ampere, we have calculated. What is R4? R4 is 1. So total is 2 volt. So we can see the potential drop across R4 is 2 volt, potential drop across R3 is 6 volt, so total is 8 volt. Just see that 20 volt is the potential drop applied across the whole circuit. So 8 volt potential drop, we can see the aggregate potential drop across this R3 and R4. So rest of the potential is applied across the parallel combination of R1 and R2. So we can say 12 minus 8. 12 minus 8, that is 20 minus 8, that is 12 volt is the potential drop across the resistor R1 R2, and it is same. So we can say very simply that is the potential drop across R1, potential drop across R2 are same, and that is simply E minus of V3 plus V4. Okay, what is E? E is 20. What is V3? V3 is 6. And what is V4? V4 is 2. If we calculate this, 20 minus 8, that is 12 volt. 12 volt is the potential drop across R1, and 12 volt is the potential drop across R2. Now if I try to find it out, what is the current flowing through R1? So that will be V1 divided by R1. What is V1? V1 is 12 volt. What is R1? R1 is 10 ohm. So you can say 1.2 amperes. Listen, this total current is 2 ampere. So 1.2 ampere flows through R1. So obviously rest of the current, that is 0.8 ampere, should flow through R2. So you can say I2 is equal to V2 divided by R2. What is V2? V2 is obviously we have calculated, it is 12. What is R2? R2 is 15 ohm. So if you calculate this, obviously you can get this answer, that is 0.8 ampere. So what we find it out? 20 volt is the potential source. Through R1 the current is 1.2 ampere. Potential drop across R1 is 12 volt. Through R2 that is the 15 ohm, the current flowing through is 0.8 ampere, and the potential drop across it is 12 volt. Through R3 the current flowing through is 2 ampere, and the potential drop across R3 is 6 volt. Through R4, that is 1 ohm, the current flowing through is 2 ampere, and the potential drop across it is simply 2 volt. Thank you all of you.